Hello and welcome to another one of our webinars. My name is Kevin Racinos and I'm the product manager of routers here at AXYZ Automation Group. Today's presentation is focused on metal fabrication, specifically of aluminum materials. We're going to talk a little bit about tools, feeds and speeds, and any other considerations we should think of as operators in order to process the material. We're also featuring our brand new Metalworker product. We launched this product back in September of 2021 at the FabTech trade show in Chicago. We're going to look under the hood, both software and hardware features, to see what makes this product so unique. Now, before I get started, if you have any questions throughout this presentation of the features or the process itself, please make sure to use the GoToWebinar application. There's a little chat box feature there. Click on it, ask us a question. We'll do our best to take up any questions at the end of the presentation. All right, let's get started with the features. So this is a Metalworker 5010 model, which has a 6 by 10 process area. Standard on AXYZ routers, there's an aluminum T-slot vacuum deck, and in conjunction with a vacuum pump and the MDF, you can hold your parts down right through the MDF. You can hold down the sheet or the parts themselves. Now, we divide the process area into different zones to maximize vacuum performance. So in this particular machine, we have 7 different zones, and we only turn on the zones that we need for the job or to maximize the sheet's hold down effectiveness. In areas where we don't have a material on top, we'll make sure those zones are off during the cutting process. Now, in terms of sizes for this particular model, we have a few different. We have about 9, but starting from a 4x4 to a 6x14. There's other sizes available upon request, of course, but again, we have typically the most common sizes for the standard sheet sizes in this industry. Now, moving up to cutting, we have 2 spindles on this machine. Both can actually go up to 24,000 RPM, but this spindle on the right is a little bit different. So this is an ISO 30 spindle, that's the tool holder, and its peak torque is around 14 to 16,000 RPM. On the left-hand side, we have a Hi-Teco model spindle, and its peak torque can go around 6,000 RPM. So that's where the spindle sweet spot is for its true power. Now, the spindle on the right is great for general purpose work. That's aluminum, that's plastics, that can be woods as well, but particularly high-speed operations. Now, the spindle on the left, however, its peak torque being at 6,000 RPM allows you to use larger tools rated for lower RPMs, such as 7,000 RPM or 6,000, that this particular spindle on the right could not handle. So when we're looking at this spindle, we're looking at larger tools. We're also possibly looking at lighter alloys that we can process. So this is the reason why we have these 2 spindle or the 2 cutting heads. On the left-hand side, we have an automatic tool changer on this machine. It is a 10-position tool changer. We have a combination of HSK and ISO tools loaded. So other few things there, we have a tool tip sensor, and that is used to calibrate the length of the tools. And so that's sitting right on the tool changer itself. Okay, so now moving over to the front here, we also have alignment pins. So the pins are used to make sure your material is oriented correctly before you start the job. And this makes it so that you're maximizing yield of the material itself. Now, specific to the Metalworker, standard on this machine, we have an 8" by 8" steel gantry tube. This is a stress relief tube. And what this does is it adds a little bit more weight into the gantry area, and it makes sure that during cuts, especially with heavier or larger tools, that you're getting that smoothness and the stability from the gantry system. So making sure that your tool motor vibrations are being absorbed by larger mass is the key here. So this is one of the reasons why we introduced this larger gantry system. In addition to that, we have a slightly larger standard carriage, which will give you approximately 14 inches of total Z stroke. We have on this machine 6 inches of gantry clearance, so you can use longer tools, of course, that can clear the space of the gantry. So now you can process materials that are 5 inches thick, 5.5 inches thick, of course, without any issues there. So other few features that we can also comment on, we have upgraded the spec on the helical rack and drive system. This machine is rated to go up to 3,000 inches per minute and has a higher acceleration. compared to other products. So we have to upgrade the helical rack spec in order to make sure that the higher accelerations can still provide you the precision and smoothness during the cut. Now, a few other things, we've upgraded the servo motors on this machine. So we're using 750 watt motors, as well as we have a 350 watt motor on the Z. And this is gonna give you a high Z speed, so 500 inches per minute on the Z for travel rate, 3,000 inches per minute on X and Y motion or moves. And so point-to-point operations, you'll see that are done fairly quickly with these enhancements. Now with this multi-purpose operator station that the screen is mounted to, you can store things like collets, tooling within the drawers of this station, making it very useful and easy access to your wrenches, to your collets, tools, or day-to-day items that you'll use with the machine. One amazing feature that we just haven't talked about just yet, and that is the software. So we're gonna go over to the software and look at what's unique there. Right here we have a program called AXYZ Move, and this is what you use to run the machine. First up, let's look at the left-hand side. We've got our outputs to the machine. At this point, we have the pop-up pin as an output. So if I click on this and leave it on, you see as it turns blue, my pins are actually turned on at the moment and they're at the highest position. If I lower it, the pins will go down. A few other things to mention here that are important. Head 1 and head 2 represents our spindles. So I mentioned we have 2 spindles on this machine. Our zones, as I described earlier, we have a few zones on this machine. We have 1 through 7, and what I'll do is I'll control zone number 1 to stay on. So this is forced on, but I also can leave it as an auto. So what you do, depending on the sheet size you're working with, let's say it's a 4x4 and it's positioned somewhere in the bottom left, you will turn off zone 6 and zone 7 and zone 5 to make sure those are off. So we can go zone 6 off, zone 5 off, and zone 7 off. So these zones won't turn on during a job unless we change this status. All right, moving over to tools. We'll click on tools for a second. And now the tools are divided in 2 separate lists. So our first tab lists the tools that we've assigned to the machine. So these are all active tools at the moment. And over here on the tool library, this would contain a list of tools that you wanted to use. So if I go and click on tool, I can add a tool, let's say a custom tool, a spindle tool, or let's call it, let's say a 1/4 inch alu tool, and we'll leave that there. The tool type can be a spindle. Diameter of the tool, we can specify that. Of course, the max RPM of this tool. And then if you have a part number that you know or understand the amount of time this tool will take until it wears out in production, you can enter these values here as well. If I click OK, you'll see that our aluminum tool has been set up. And if I wanted to, I could also assign it to our main machine tools list. If I click on this tool over here, it's going to ask me if I want to perform a tool change. I'll do it. I'll click yes, and I'll go drop off the tool. And now that it's dropped off the tool, let's see that my tools list is empty. So let's return to no active tool. If I go and click on it here, I'll go and pick up a tool. All right. Okay, so that just shows you the feature there. Over here on the right-hand side, let's talk a little bit about other settings and options. So if I click on settings here at the top, there's a few specific software settings that you're allowed to predefined. You also have different type of users with move. Right now I'm a general user. Move allows you to move either incrementally from your relative position or in absolutes. So we can move, let's say, 5 inches from where we are, and then we click on move and the machine will move. And then you can also do that from an absolute coordinate system perspective. A few other options as well, including offsets. So you have different offsets you can set up depending on your origin and positions. Over here on the machine tab, we have a feature where you can actually set up your wasteboard, and this will allow you to define the thickness of the MDF, and of course you can also clear that and so on. You also have a warm-up spindle routine that can be actuated through this option there, or triggered through the option there. Let's talk about jog controls. So we have a few different options here. We have the fast, the medium, and the slow, represented by the snail. So if I go over and jog in the Y, you'll see that the machine moves. You'll see a little cross here as well, move with it. Move there. Now if I do a diagonal move, the machine will move as well. So this makes it really easy to move the machine. You can also change the speed and jog the machine at a different rate. We can make it even slower and jog it at a snail pace. So kind of what it calls. So right now we're in continuous jog mode, represented by this option here. So if we wanted to be more precise, we can also move over to an incremental jog mode, and then rather than moving, let's say, 10 thou per click, we can also move, let's say, 1 thou per click. So this is a convenient feature when you're doing high precise setups of parts, and you want to make sure you're at the right location. Okay, there's a few other things here. Below the direction keypad, we have our positions, so current positions of our active heads, and that is pretty useful for us to know as when we're setting up parts, we're making sure our locations are set up for our work offsets. This will be our guiding points. Other options as well, if you click on the option here, you have your feed rate and your jog settings. So now that we got the basics of the control system, I just wanted to speak a little bit about how to drop off or load a part. So loading a part is actually quite easy. You can do that by clicking part here, and if you click part, you can load new parts or new jobs in by clicking this button here and then navigating to your specific drive. So there's a couple ways to do this as well. I'm going to show you one particular popular way, of course, is to just drag and drop. Let's pick up a folder and look for a file. So I've got a pre-programmed file here that I'll drag over, and just to show you what that looks like. So this is the part that I just dropped off. It's one single part, though you can have a nest of different parts. So a few other options. If you click on the part itself, you can array it. You can also add some more cycles. If you want to repeat that specific job, you can definitely do that here. You can remove the program, mirror it, rotate it, or lock it from being modified. You can also drag this part and load it somewhere else, maybe closer to the front left of the machine, and I can run it. A few different other things that you can do and move, specifically with the way you can queue up your job, such as the bottom left feature here. You can have one, or different types of nests. So that you can see that as well. If I pick up another job and I load it back onto this part. So if I copy this, for example, let's do a duplicate file. I don't always recommend this, but let's just do this for this job. and just call it ALU, and I'll dump that over to the machine as well. And you can see that we have 2 part programs, and these are 2 individual NC files. So at first, the first one we dragged in will run, and then it'll run the second part. So let's remove that. And now that we've done a quick review of Move, let's jump into the cam side. So let's jump into Vectric's Spire program, which we have here. For this job itself, I've gone ahead and broken up the part into different sections. So what we're going to be doing here is cutting all the way through this circle, these 2 circles here. We're going to be doing pilots or drill holes right through these 6 circles you have here, going right through here as well, and then doing a bit of a pocket. So if I can simulate this tool path, then I can better describe what's the outcome here. So let's bring this over here and bring it up to fast speed. Let's do preview all tool paths, and I'll show you what exactly it's gonna do. All right, so the highlighted in yellow is a representation of the tool path itself, so that's engraving or the pocketing. Let me click on the offcuts so that I can only focus on the part itself. So here's the part that we ended up with. You know, I can rotate it a little bit here, see what that looks like. So this is just a funky shape that we have for this presentation. Like I said, this is a transmission of sorts. All right, so if we wanted to send this file over to the machine, we would go and select all our tool paths. So let's save that to our cam folder. I have an example here. So we can call that, you know, test 2 or test 1. Should say, and save that, and I would save it to our known location on our computer. And like we did before, we can transfer that file over to the machine. Similar, you know, you can drag it over. Here's our test file, and it would be placed onto the machine. Now that we have the basics of how to use the Move CNC software, let's go set up the tools for the job, and let's go run that part. All right, let's get started with our tool setup. So over here we have 2 types of tool holders. We've got an ISO 30 and an HSK 63F. Our 11 horsepower spindle that I mentioned is equipped with this type of tool holder. We'll put this on the side for now, as we're working with the ISO 30 today. All right, so in terms of assembly, we've got an ER32 cover nut, an ER32 collet, the 8mm tool we're using today, and our torque wrench and ISO tool holder. So what I like to do first is I like to start with the cover nut, and before I assemble anything, I make sure that the threads are nice and clean. We don't want any debris. Same thing goes for the collet. Make sure it's nice and clean, it's in good condition, so that it grips the tool as best as it can. The tool that we have, or we're using today, is an 8mm O-flute tool. This has a special coating specifically designed for non-ferrous metal application. Now we'll place and install this tool right into our collet. What we're going to make sure is that over 80% of the tool shank is installed, and now we have the tool holder. So I'm going to drop this off of my tool changer, and then you're going to see the tool in action.